Okay, so I'm going to record the intro lesson that we did on Wednesday/Thursday for this new objective. So in case you forgot, we're on objective 8, and it is I can balance chemical equations There we go. So I can balance chemical equations, proving how reactions observe the law of conservation of mass. After I gave you this, I gave you a situation where we have a chemical equation that represents a chemical reaction. So a chemical reaction would be methane burns with oxygen to produce carbon dioxide and water and release heat. So this would be our chemical reaction. This can also be represented as a chemical equation. And I'm going to have to do this by drawing it. CH4 plus O2 produces CO2 plus H2O. So in a chemical reaction, we've got, in a chemical reaction, this is what we see and what happens in front of us. Chemical equation is a way that we model it. So this methane is represented here. We've also got burns with oxygen, and the oxygen is right here. It produces carbon dioxide right here, and water, which is here. So this chemical reaction is represented as a chemical equation, always knowing that our chemical reaction has a produce part to it. The produce is the arrow, telling you the left side is the reactants and the right side is the products. So we're going to look at the 3 steps to a balancing chemical equation. So let's begin. So in order to balance a chemical equation, we're going to look at 3 steps. Let's put the 3 steps over here. Let's see. No. Black. Black and yellow, black and yellow, black and yellow, black and yellow. Step 1 is to first count the number of each atom on each side. So that's what we're going to do first, using the same equation that we used in the chemical reaction and chemical equation part. So I've got CH4 plus O2 produces CO2 plus H2O. 2. Okay, so first we need to count the number of each atom on each side. So we're going to start with a table. On the left side, reactants. On the right side, products. And the atoms that we have, we've got a carbon on both sides. We've got H, and we've got O. These are the 3 atoms present on both sides. So in order to count both sides, we need to, so I'll do this in red to show that it's first step. Okay. So on the left side, we've got carbon right here. It would have an invisible 1 right here. The 4 only touches the H. So the 4 only goes to that. So the carbon would be 1 carbon. The hydrogen would be 4 hydrogens. And then the oxygen would be 2. So what this shows is that 1 carbon is connected to 4 hydrogens. And then here 2 oxygens are connected to each other. The bonds break, just like we learned, the bonds of the reactants break apart and they reorganize into these products. So carbon, 1, hydrogen, 2. It has 2 because this little 2 affects only hydrogen. And then oxygen would be 3. The reason why, we've got 3 oxygen. Sorry, we've got 2 oxygen here plus the one that's right here. So we've got 3 oxygen. Okay. Now let's work on step number 2. And let's do step number 2 in step 2 is to change the coefficients. Why is it doing that? Change the coefficients. So you want to change the amounts of each molecule to make the amount of atoms equal on both sides. There. So the coefficients would be the big numbers in the front. The little numbers are the subscripts. So we've got, let's do this in black. Oh no. No, oh no, oh no. There. Let's draw. Let's just continue. In blue, we're going to balance out both sides. So balanced equations, it's about these reactants. We've got 1, 2, 3, 4, 5, 6, 7 atoms here. And we ended up with 1, 2, 3, 4, 5, 6. So where did that? Where is the change coming from? Because nothing gets made, nothing gets destroyed. Law of conservation of mass says everything has to get conserved. So we're going to start with the one that seems the most straightforward, which would be H. The reason why? This 2, we can multiply by 2 to get it to be a 4. So to multiply by 2, you would need to, again, do coefficients. Coefficients, in this case, would be putting a 2 here. That is a, oh, it's going to get tricky, coefficient. With this coefficient, it affects what we want it to affect, which would be the H, but it also affects the O because those come together. So H's, now we've got 1, 2, 3, 4. So 2 times 2, 4. And then now O's. Here we've got 2 oxygens plus the 2 that are here. So now we've got 4 oxygen. And now, so carbons, we were good. Hydrogens, we're good now. Oxygens, now we need to take care of. What can we multiply times 2 to get it to equal 4? We would put a 2 as a coefficient here. So we want to multiply the amount of oxygens here. So now we've got 4. Do we have it balanced? Let's see. 1's on both sides, 4 on both sides, 4 on both sides. Yes. So we're good. And that brings us to then step number 3. Step 3. Let's do step 3 in brown. Step number 3 is that you are going to review that your equation is correctly balanced, because you don't just want to submit whatever. You want to make sure that whatever you submit is correct. So how I'm going to do this. So I'm going to do step 3 separately. I'm going to draw. I'm going to do this in brown. CH4 plus 2O2 produces CO2 plus 2H2O. The struggle. So I just copied down what we ended up with. That way it's less cramped. So let's see. Carbons. Carbons on the left side, we've got 1 carbon. On the right side, 1 carbon. Now, hydrogens on the left side. The reactant side, we've got 4 hydrogens. And then on the right side, we've got 1, 2, 3, 4, because it is multiplied. 4 hydrogens. Now oxygens. Here we've got 2 times 2, 4 oxygens. And then on this side, we've got 2 oxygens here, plus the 2 oxygens that are right here. So we've got 4 oxygen. So that would be our final answer. Let's put it in yellow. That way it gets attention. What am I doing? Ta-da! That is our final answer. Now, we are going to select, no. Okay, what we're going to do now is I'm going to show you why this would be balanced and why we did this and this. So let's clear all drawings. That was a lot of work. Okay. Wait. So right now I'm just going to answer some potential questions that you might have in your head. So when we put the 2 right here, we did this in order to have 4 hydrogens. So we've got 2 hydrogens. We wanted 4 hydrogens. The reason why it also affects oxygen is because we've got a water molecule is this. That travels together. If you want double the hydrogens, what you're going to have to do is double the amount of water molecules. Oh, what was that? And then we've got, let's see, I'm going to do pink just because. So here we've got carbon with 2 oxygens, oxygen, double bond to a carbon, double bond to an oxygen. Double bonds because, go back to objective 4, figure it out. Here we've got oxygen, double bond oxygen. And then here we've got carbon, hydrogen. Wow. We've got on this side 1, 2, 3, 4 hydrogen. This side 1, 2, 3, 4 hydrogen. We've got 2 oxygen, 2 oxygen, but there's also these 2 oxygen, which brings us to why we put a coefficient of 2 here. We want to make sure that we start with this. We start with 4 oxygens. Once we put in that activation energy to break the bonds, we've got 4 lonely oxygen, and then those 4 lonely oxygen, 2 go to the carbon, and then 1 goes to hydrogens, and the other 1 to hydrogens. So there's, as you can see, it's balanced on both sides. We take into account everything that's there. So if you were tasked to work with this chemical reaction, you have to take into consideration that it would be double of the O2 plus the 1 of the methane coming together. It doesn't just take 1 and 1, it's 1 and 2. Okay, let me know if you have questions. Hopefully this was understandable and hopefully this helps. Okay.